Okay, so this is the weekend one. Um, okay. A spinner with 7 equal-sized sections was used to play a game. Why is this familiar? It was used 250 times. Out of the 250 times, it did something. It landed on 7 a total of 35 times. So I can write it this way. P of 7, it landed on, out of 250, it landed on 7 35 times. And then the spinner was spun 150 more times in the second game. How many times did the spinner most likely land on 7 in the second game? So this is our probability of the first 250 times. So we're going to use these results to predict out of 150 how many times it landed on 7. So it's just this, or 250. We can simplify. So this is going to be 3/5. Simplify again. And 7 times 3 becomes 21. You could have just put that in your calculator, but you're still going to get 21. So that's using the experimental probability, right, to make a prediction. Number 2, Amanda surveyed 13 students in her class about her height in inches. Here's her data below. Which box plot correctly displays her data? Are these numbers in order? Yes, they are. So right away, we can look for these two. Anything that has a 52 as a min and 65 as a max is something we want to consider. This is already gone because it doesn't have the min as 52. This one also is gone. So now we're left with A and D. So A and D both start at 52 and both end at 65. So let's find the median. And the median would be, let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 1. And the median is 58. Does either of them have a median 58? Yes, this one has right here. So right away, A is our, what do you call, correct answer. Easy. 3. Uh-oh, I don't like when they can't see the whole thing. So number 3, the graph below shows the total distance in miles traveled by a towboat over time in hours. So we're looking at that. Which statement best describes the meaning of the coordinate f? Coordinate f is here. Well, it says, I'm going to write it as a fraction, that the total distance was 5.25 miles. And how much? In 1 hour. So that's our unit rate, right? So A shows the unit rate of the graph in hours per mile? No. It's not hours per mile, it's miles per hour, so that's gone. Shows the unit rate of the graph in miles per hours? Yes. Winner. It shows the time in hours it takes the towboat to drive 1 mile? No, it doesn't show that. It shows the distance traveled in miles by the towboat after 5.25 hours. No, it doesn't. It shows the miles traveled in 1 hour. So that's the one we want. B. A computer program selects red, blue, red, or green as a background each time the program is used. The program was used 45 times on the same computer in 1 week. So we turned on the computer, and out of the 45 times we turned on the computer, a blue came out 12, so I'm going to write P of blue 12 times. The red, P of red, was 21 times, or 21 out of 45. And then there was one more color, green, right? And P of green, obviously, has to be the leftover. So out of 45 times, 12 was blue, 21 was green. So let's add 12 plus 21. That's going to give us 33. 33 minus 45 means that 33 minus 45 equals 12. So green was also 12. So based on that, what do you call, what they want to know, what's the likelihood of green appearing in the next time? Well, out of the first 45 times, green appeared 12 times, right? So let's see the next time, the likelihood it's going to be what? A, green is just as likely as red or blue to appear? No. Green is just as likely as the blue, but not as the red, because the red showed up more, so that's garbage. Green is just as likely as a blue to appear. Yes, green and blue showed the same amount, but not as likely as red. Good, because red, as I said before, had a greater chance. So B seems okay right now. Green is not as likely as red or blue to appear. That's not true. Green is likely as blue, but not red, so that's garbage. Green is not likely as blue to appear. No, that's not true, because green has the same probability as blue, so that's garbage. And the other one was, the only one that we had left was B. 5. Which number represents the probability of an event that's likely to occur? Okay, remember, and I think I chose this for one of your days. So again, 0 is impossible, and 1 is certain for sure to happen. Or this is 100%, and this is 0%. So we can put these numbers on number line. 0.12 will be about here. 1.3 will be way out here, right? So that's not even 100% is for sure. So 1.3, there's no point of writing 1.3. And we're not looking for something that's more than 100%. Okay, more than more than certain. So that's not even a consideration. 0.89 is here. So that's very likely to happen. That's the one we know, because 0.09 is way over here. Well, the only number that represents something that's likely to happen, not guaranteed, but very likely to happen, is this one. That would be C. Which expression is equivalent to n plus n minus 0.18n? So let's just add them. And you can treat them like this. So pretend there's a 1 here, pretend there's a 1. Since they're all like terms, we're just literally adding the coefficients. So let's forget the n's for a second, and we'll just keep the numbers. So we're going to get 1 plus 1 minus 0.18. Think of it as $1 plus $1 minus 18 cents. $1, $1 is $2 minus 18 cents is going to be $1.82. And it's going to be $1.82, and we have a winner. 7. Nick's making bread dough. Okay. The recipe requires, so let me write that. 3 cups of flour, 3/4 cup of flour, and 1 1/8 what do you call teaspoons of salt. Nick wants to make the recipe using 1 cup of flour. So if I use 1 cup of flour, how much salt do I need? Let me just reverse the order here. So 1 1/8 salt for every 3/4 cup of flour. So what happens when I use 1 cup of flour? Obviously, I'm going to use a little bit more salt. So change the unit rate, multiply by the reciprocal, 4/3, and multiply the top by 4/3. These two cross out, simplifies to 1, which is what we want, and then multiply 1/8 times 4/3, which you can do in the calculator. I'll just do it on the side here for you. 8 times 1 is 8, plus 1 is 9, so that's really 9/8 times 4/3. If we multiply, and we can simplify before we multiply, that becomes 1, that's 2, that's 1, and that's 3. Final answer, 3/2, or 2 goes into 3 one time, 1 left over 2. So we're looking for 1.5. Number 10. At a store, a hat has a regular price of X dollars. During a sale, the price of the hat's discounted by 20%. The expression 0.8 describes the discounted price in dollars of the hat. So that makes sense, right? So if this is the price of the hat, and you want to know how much you're going to pay, well, they're giving you a 20% discount. If they give you a 20% discount, that means you're going to pay for 80%, right? And we can multiply the price of the hat, the original price, times 80% to see what it's going to give us. So it's multiplied by 0.8. So that's the operation we would do to find the price after the discount. The expression at 0.8x is which is exactly what we have. Shows the price of the hat after the discount. Which expression also describes the discounted price and the price of the hat. So one of these three, A, B, C, D, also represents this value. So this, and I actually like it the way they wrote it, 0.8x. Now, if you compare A is 0.2x, the same thing as 0.8x? No, garbage. It's x minus, so x, so again, in front of every x, or just a variable, I'm going to put a 1. For that says 1x minus 0.2. Well, the problem here is that I can't subtract these two, right? Because one has a variable, the other one doesn't, so that's garbage. Again, look at this one. X, in front of that x, there's a 1. If I want to subtract, even if I wanted to subtract these two, I wouldn't be able to. 1x minus 20, one is a variable, the other one doesn't have a variable, it's just constant, so garbage. And the last one, you notice that both terms have an x, so I can subtract those. And honestly, I'm going to put a 1 over here, so that's 1x minus 0.2x. So remember, when the variables are the same, you can just put the variables here and focus on the coefficients. And if you do 1 minus 0.2 in your calculator, you get 0.8. So that's how D is the one that's equivalent to that. Eight. So this is distributive property. We're going to distribute this like this, and then subtract 3. So let's take the first part. It's 1 over 3 times 6x. 1/3 times 6x. And that's going to give us, well, first of all, negative times a positive is going to be a negative. Let me put this over 1. You can just simplify this in your calculator, multiply in your calculator, or just multiply right now. Well, 3 and 6 can be simplified, right? 3 divided by 3 is 1. 6 divided by 3 is 2. So we get 1 times 2 over 1, which is just 2, but negative. And don't forget the x. Negative 2x. So anything that starts with negative 2x, we should consider, and all of them have negative 2x. So now we're going to do the second part. Negative 1/3 times positive 15, right? Because a negative times a positive is going to be a negative. So the second thing is going to be, second term starts with this, right? Because first one was negative, positive is a negative, and then negative, positive is also going to be a negative. So if you look at your answers, anything that has a positive is going to be wrong. So this is wrong, and this, I'm sorry, not that one, and this is wrong. So 1/3 of 15 is 5, right? And then finally minus 3. Let's combine like terms. I can combine these two over here. So I get negative 2x and negative 5 minus negative 3 is negative 8. And here's my answer. 11. Here is the Statue of Liberty. The model. This is 15 inches tall. The scale model of the scale of the model to the actual statue is 1 inch equals 6.2 meters. So every inch in this model, the toy one, the toy Statue of Liberty here, every inch represents 6.2 meters in real life. So which equation can Howard use to determine x, the height in meters of the Statue of Liberty? Well, you would have to set a proportion, so you can write a proportion in this manner. This is our ratio. 1 inch in my toy Statue of Liberty represents 6.2 meters in real life. Now, if my toy Statue of Liberty is 15 inches tall, right? Always have units side to side the same, and here I'm going to put meters. If my little toy here is 15 inches tall, how many meters would that be in real life? And that's how we would set up our proportion. So, is there any of these four? Well, that looks like this, or let's see, 1 over 6.2, x over 15. So this is very close, but it's not, because 15 should be on top. This is wrong. 1 over 6.2 equals 15 over x, and x represents my question mark, right? And this is what okay. Josh has a reward card for a movie theater. He receives 15 points for becoming a card member. He earns 3.5 points for each visit to the movie theater. He needs at least 55 points to earn a free movie. So every time you go to the movie theater, you get 3.5 points. You also got a bonus 15 points just for becoming a member. So he needs 55. We want to set up an inequality to see how many more points he needs to get a free movie. So we know so far he has 15, right? Because he got 15 bonus points for opening the card. So whatever I know, what I do know, and I hate that they do this, you know, I mean, nobody, I forget it, I'm not going to complain. But let's set up our, inequality. So I have 15 points. Whatever I gather here, whatever I need to get here has to be greater or equal to 55, right? That's what I need. So that every point that I collect, everything that I have on my card has to be greater or equal to 55. I get a free movie. So far I have 15, plus I can get, or he can get, 3.5 points. He's going to get 3.5 points for every time he goes to the movie theater, every time he watches a movie. So I'm going to put 3.5 times however many movies he sees. Right? So if he catches a movie tonight, he gets 3.5 points. If he catches a movie tomorrow, he gets another 3.5 points. So every time he sees a movie at the theater, he gets 3.5 points. But don't forget, he also had 15. So we're looking for something that looks like this. So that has to be greater or equal to 15.55. And notice that in their answers, everything starts with 55. So we got to sort of look backwards, right? So we got to switch this backwards. So, and one way of doing that is simply throwing the 55 to the other side, throwing 15 plus 3.5 m to the right side. But when you switch sides, you gotta switch sides, right? So is there anything that looks like this? 55 less or equal, yeah, right there. Sorry, this is 15. 55 less or equal to 3x, 3.5x or 3.5m plus 15, which is what we have here. And that looks like this. Okay. The regular classroom floor is 36 feet and 36 feet in length and 32 feet in width. So 36 and 32, so that's the classroom. A scale drawing, so somebody drew a little map, a little drawing of that classroom. And in that classroom, the floor length is 9, right? What is the area in square inches of the floor in the scale model? Well, I want to find the area. To find the area of this little scale model, I have to do length times width, but I don't have the width yet. So let's see if we can get the width. So how did the 36 become a 9? And notice that these two, we're talking about the same side, right? The length in real life, the real class, and the length in my drawing. 36 to 9, right? So it's divided by 4. So the width of the real class and the width of my drawing should also follow the same pattern, which is divided by 4. So I'm going to get that it's 8. Now, can I find the area of this little rectangle? Well, length times width, 9 times 8, and I get 72 inches squared. Right? So you first have to do this to finally get the area. 13, Mr. Trager at $500 to spend. Here, all prices include tax, okay? He buys a new bicycle, he buys 3 bicycles. What's the greatest number of recycling outfit? Okay, he wants to buy a bike, 3 reflector, 1 helmet, and the remaining money he wants to use it on outfits. So what's the greatest number of outfits he can use? Sometimes you gotta figure how question, which is pretty much addition and subtraction here of just money, has a place on this test. Just seems out of place. So here is 500. Let's subtract the bicycle. It makes no sense. 500 minus 273.98. So he has this much left over. So once he has this much left over, he's going to buy 3 bicycle reflectors and multiply 723 times 3. It's going to be 2169, so let's subtract that. And we also got to subtract the helmet, which is 42.36. So let's do that. So 226.02 minus 21.69 minus 42.36. That's going to leave us with $161.97. Now he wants to buy bicycle outfits. Well, it's 78.12. So 78.12 is about 80. And 80 goes into 161 about 2 times. So the greatest number of outfits, we don't even have to figure that out, is 2. And he'll get some change on top of that. So that would have been our answer. 14. He wants to rent a car. It's $20 per day and $10 for every mile. He will travel 250 miles. He has 100. He has $150, $15 to spend. Write an inequality that can be used to determine D, the maximum number of days that Jim can rent a car. So here's what I know. $21 times per day. So 1 day is $21, 2 days will be 42, 3 days will be 63. So it really depends how many days. So 21 days, he's going to rent a car. Not 21 days, $21. He's going to rent a car. We don't know for how long yet. We know how far he wants to travel. He wants to travel 250 miles. And every mile is 10 cents. So let's figure out how much that is. So if you multiply 250 times 10 cents, right? 250 times 0.10 equals $25. So just based on the miles, I know he's going to spend $25. So let's add it to here. So it's going to be $21 times however many days, plus $25 because he's going to travel 250. And all of that has to be less or equal to 115, right? Because he doesn't want to spend more than this. So however many days, plus $25 for all the miles that he's going to drive, all that added together has to be less than 115 days. So how many days can he drive the car? So, well, let's solve this. And again, we can do minus 25 here, minus 25. 115 minus 25 is, I don't know, 90. And then we're going to do 21D. So divide by 21, divide by 21, and D is less than 90 divided by 21 equals 4.28 or 4.29 rounded. So the greatest number of days, right, that he can, what do you call, complete days that he can rent this car is, has to be 4. Right? Anything above 4 complete days, right? So it says complete days, not days and change. So the greatest number of days is 4, and then you can figure out how to answer that question. Okay. And actually, I'm going to put this on number line so you can see. So here is 4.29. So any value that is 4.29. Remember, this is shaded because it has an equal sign and points that way, right? Any value less or equal to 4.29 will make this inequality true. So if I pick a number on this side and I put it over here, it's not going to be less or equal to 150. So I'm going to put 5. So this question says what happens. He believes that he can rent a car for 5 days. Well, let's show them what 5 days equals to. So it'd be $21 times 5 days. Plus 25, and let's see if that equals to less or equal to 115. 21 times 5 is 105, plus 25 is less or equal to 115, and 105 plus 25 is 130. So right there, you can tell that this would cost more than the 115 that he's willing to spend. Are we done? Oh, yes. And we're not done. Jennifer has 84.5 yards of fabric. She wants to make 6 identical curtains and has 19.7 yards of fabric remaining. She makes 6 identical curtains and has 19.7 remaining. So she had this much. So if she has 19.7, we can figure out how much she used. So if I subtract this, that's a leftover fabric. 50 minus 7 is 8. What is it? 13 minus 9 is 4. And we borrow from here too. So 7 minus 1 is 6. So she used this much in her 6 curtains. So we want to find out how much she used per curtain. So she used 64.8 in total. Divided by 6. Divided by 6 equals, she used 10.8 yards of fabric per curtain. Now I know I'm done. Okay, and that's it for the weekend.